All right, welcome everybody. Today's talk is building real-time web apps with App Engine and the Feed API. My name is Brett Bavar, and I'm a software engineer on the Google Ajax APIs team.
And I'm Moishe Lettvin, and I'm a software engineer on the developer platforms team.
If you want to view live notes or participate in the wave for this session, you can go to this URL. I'm going to leave it up for a second and read it off to you because it's kind of crazy. bit.ly/DC6QX. Or if you've been doing waves, you should be able to look through kind of the official Google I/O wave list, and you should find our session amongst there with the wave button, as well as I believe on the official Google I/O website. For the information on this session, you should be able to find the wave button is there as well. All right, so before we get started, I wanted to give you just a little bit of context about what we're talking about when we say the real-time web. So I'm sure all of you are familiar with this site right here, google.com. And for a long time, google.com has made it, search results available to us. Say I wanted to search for what people are saying about Google I/O. And you can see here I get some very good results, but they don't change. When I'm viewing the page, they just stay the same. I'd have to refresh if I wanted to get new content, and it's probably not even going to change that frequently anyway. But one thing I can do now, as you may know, is there's a new version of this called Google Real-Time Search, where I can see new things that are coming in. You can see right here, 24 seconds ago, something was said on Twitter about Google I/O, and things are continuing to come in. This is one example of the real-time web. Things are coming in constantly, content that users are interested in, and we want to make it available to them as easy and fast as possible without having to refresh the page. So this is one example of the real-time web, and lots of people are trying to add this to their web apps and their websites, but it's not as easy to do as you might think. So we want to talk to you about some new ways that you can add this kind of real-time functionality to your web page. So we're here to announce and explain two new tools for this. First, the App Engine Channel API, which Moishe has built and will introduce you to, that allows you to push things in real time in App Engine. And second, I will talk to you about Feed API version 2 with the new functionality for push updates on feeds. And at this point, I'll pass it over to Moishe to explain the App Engine Channel API.
Cool, thanks, Brett. So I have a brief agenda of what I'm going to cover here. So I want to talk about, as a way of introducing this API, I want to talk about how things are now and a problem that you may have run into with the way things are now in App Engine. Then I'll describe what the Channel API does to solve that problem. Then I'll talk about how to use it. I'll show some code snippets and how it works under the covers briefly, some implementation details. So to get started, have you guys all used App Engine? Do we have App Engine developers in the room? Oh, sweet. Yes. All right, so you know the basic flow, right? App Engine is basically, you write your app as a bunch of request handlers. So typical case, a user types your app's address into the browser. They navigate to your site, and you get a request in your app. Your app delivers a response down to the browser. The browser renders your client page. And then that's kind of it. Like, your browser now has the bundle of JavaScript and HTML and whatever data you deliver to it, and the user can interact with that. The problem is, so let's say you're writing a chess game, just a simple two-player chess game, and the other player makes a move. Some event happens to your app. Your app's state in the cloud changes. How do you tell the client that happened right now? Anybody? How do you tell the other person in this chess game that somebody moved their rook up, or moved a pawn, or captured your queen? You poll, exactly. And this is a pretty common case, right? There's this really neat app that somebody wrote called cmycode.com. I don't know how many of you guys do phone interviews, but like a really common kind of challenge with phone interviews is you want to talk to somebody over the phone and see if they can actually write code before you bring them on site to see if they can write code even better. But it's super hard to dictate code over the phone. When I did my phone screen for Google, they asked me this complicated thing, and I had a notepad with like 10 pages of code, and I was trying to dictate this over to my interviewer, and it sucked. So this guy wrote this cmycode.com website, which is awesome. You go there, and you basically see as the other person types what they typed in. But he has to use polling to do that. So that's an example of something where you end up falling back to polling. Chess games, if you want to write a group chat on top of your app, you'd need to do polling. Basically, any time that there's a person who you're interacting with on the other side, where there's no set time limit where something happens. You don't have a good way to be notified when something's changed. So you could use polling. But as you're probably aware, if you've ever written anything with polling, polling sucks. And why does it suck? Here's a typical flow. You set a set interval call in your JavaScript to ask your app up on the server, did something happen? Nope. Did something happen? Nope. Something happen? Nope. Eventually something may happen, but you're putting a lot of load on your service for nothing, really, for something that may or may not happen. So the other thing that stinks, I actually just had to write a polling implementation for the development app server for the channel API so that we could simulate this on your own machine without comment. So you end up like having all these queues of messages that are waiting to be delivered to your app, and then you've got message delivery happening on the JavaScript and your client side. And it's a big pain in the butt, and everybody ends up writing that same basic code over and over again. And it should be a solved problem, right? So the other thing about polling is if you want any sort of reasonable latency, you're going to drive your CPU and quota use up. Or if you want to pay any reasonable amount for CPU and quota usage, your latency is going to go down to something that might be unacceptable depending on your app. And what you don't see on this graph, because it's not 3D, is, of course, this whole curve gets pushed out a lot as you get more and more users. So I have a solution for you. Same basic flow. Browser makes a request to your App Engine app. Your App Engine app delivers a bundle of JavaScript, HTML, and data. But bonus, your JavaScript app creates a long-standing common connection up to the App Engine service. It's not actually connected to your app. It's connected to a Google server that's able to push data down to it. So now, when something happens in your app can notify your client that there's something new there. So the API itself is much easier than ginning up your own polling API where you've got to deal with messages and so on. And also, it lets you just step off this curve of latency to CPU use. I don't have exact numbers for this yet. The PMs are still figuring that out, but it is cheaper and significantly faster. So I'd like to show a demo of this, and you guys are welcome to join me in this. I'll tell you the URL. So if you go to iotriviaquiz.appspot.com.
I'm there.
Sweet. So now we'll set up the game. We got some questions. You guys can shout out answers to me, and I'll answer these. The author of a webcomic of romance, sarcasm, math, and language. All right, Randall Monroe. And now you see other people are joining in. You can see there's an activity stream at the bottom that's being updated as people answer questions. And there's no polling involved in here, at least no polling that you as a user of this API have to worry about. And we can actually look at the, if we look at the Chrome resources here, you can see that there's these binds. This is the comic connection that's happening. And there's posts that I'm making up to the server when I make a response. But there's no, like, if this was a polling app, you'd actually see, like, every second or every 10 seconds or whatever, another request going up. And you don't see that here. So that's that. Now, one thing to note with this app is we are sharding. There's 10 users per game. So if you don't see your name up here, that's why you're in a game with another set of 9 users. So let me tell you how to actually build that. First, let me close it. So you can see there in the upper right, there's a little key. And basically, I'll highlight whether I'm talking about server code or client code as I talk through this. It should be pretty obvious because it's Python on the server side and JavaScript on the client side. So to start with, when you get a request in your app, you'll have a get handler for your index page or whatever. And there's basically 2 calls you need to make. The first is you create a channel. And you can see that you specify a key to identify that channel. That's up to your application to provide. And it can be whatever you want. What I usually use is get current user ID. Basically, I have one client per user. But you could use a database key or whatever you choose. And you're given back an ID, which is a token that the client uses to connect to that channel. So the next line, you can see here that we inject that token into a template, write that out as the response. Now on the client side, similarly, this is a template, so we're getting that channel ID that was injected in previously. We use that channel ID to create a new channel. Then we open a socket on that channel and set a callback handler for when an event happens on that channel. So very straightforward. I mean, that really is all there is to the API. There's a few other event handlers and the like. But in essence, you create a channel, you pass the token down to the client, you open that channel on the client, and you set callback handlers for when things happen. So and then, of course, now you've got this channel open on the client side. Something else happens. You've got your other page, your make move or your answer question page or what have you. And you send a message to that channel with the key that you used above to create it. Not the ID that's handed back, but the key that you used. And then a string message. This is typically like a JSON encoded object that you can decode in JavaScript or whatever. But it's just a string. Whatever you want to put in there, you can. And then when you do that, the callback handler is called on the client side. And in this case, we alert, but you'd update your UI as appropriate based on that. Some quick details. The Python implementation, again, is just two methods, create a channel and send a message to that channel. Java implementation is the same. Obviously, syntactic differences, and you pass a channel message object in for Java instead of just 2 parameters, but it's effectively the same thing. A couple more details on the JavaScript side. You include this _AH channel JS API. _AH is like the App Engine kind of internal stuff. So we have this JS API. Depending on whether you're running on the development app server or in production, this will return you a different bundle of JavaScript. So we basically do a redirect in production. On the development app server, it's our clunky polling implementation that at least lets you try it out before pushing it. And this socket, you may notice, instead of just opening the channel, we open a socket on the channel. And the reason for that is we want to maintain compatibility kind of moving forward with the WebSocket API. So the object you get back from channel.open is a normal JavaScript object, but it mirrors this functionality. It has all these methods on it. It will set the ready state. Buffered amount it doesn't use because it's not relevant here. But the idea is that in the future, if we can support WebSockets for this channel API, we will. And it'll be a transparent switch for people who are using this API. A couple more implementation details here. Before I just had this big generic block for App Engine. The way this actually works is App Engine will talk to the Google Talk Xmpp layer. So we're using, I don't know if you guys are familiar with the Xmpp API for App Engine already. We've basically built this on top of that. So we can use our existing stack, this very, very scalable stack, to deliver Xmpp messages for this stuff. And so basically it's routed through the whole Talk stack to get messages down to your app. And on the client side, since we're connecting to Talk front ends to get these messages, rather than a server on your domain, we create an invisible iframe that actually handles the long pull, the comment connection, up to a Google server, and then communicate from that iframe using Closure XPC. I don't know if you guys are familiar with this, but it's a way to do communication between frames on different domains inside a browser. And it'll basically use whatever the most efficient method is for the browser that's hosting it. So the flow is you get a message down from the Talk front end. It's then translated into an XPC call out to your frame, and your callback is called. That's what that shows. So the status of this is it's coming soon to trusted testers, probably early next week. On the Wave, I'll add a link for you to sign up if you're interested in being a trusted tester for this. And we're shipping very soon. And with that, I'll hand it off to Brett.
Thank you, Moishe. And take a drink. I can get this open. All right, so I'm very excited about that API. Thank you, Moishe, and hopefully you see the usefulness of this, particularly if you're working in App Engine and you want to control both ends of a real-time stream of data in your app. But there's also a lot of data out there, real-time streams that exist that you don't control. And what can you do to kind of harness the power of that in your own web apps? Well, I'd like to give you one solution, and that is the version 2 of the Feed API with push updates. To give you a little agenda of what I'm going to talk about, first I'm going to introduce the difference between Feed API version 1, which you may be familiar with, and Feed API version 2, focusing on the difference between simply loading the contents of a feed and subscribing to updates on a feed. Then I'm going to get into a little more detail of how exactly do you load the contents of a feed in Feed API v1, so that we can then see how simple it is to migrate from that to subscribing to the contents of the feed on version 2. Then we'll talk a little bit about implementation details, what's happening under the hood, how are the updates actually getting to the browser, which is quite similar to some of the things that Moishe just showed you. And finally, I'll show you a few of the advanced uses of the Feed API, some of the function calls and things that are available to you if you want to do more than simply subscribing. So the difference between Feed API version 1 and version 2, as I've briefly mentioned before, is the difference between loading and subscribing. In the first case, in Feed API version 1, the Feed API makes it very easy for you to load the contents of a feed in a format that's easy to consume in the browser, which I'll talk about a little bit more later. It sends it to the browser in JSON so that it can be used in JavaScript natively. However, it only loads what the current contents of the feed are. And in order to continue to get updates on that feed, you have to do polling, like Moishe was talking about earlier. In Feed API version 2, instead, you subscribe to the updates on the feed. And for any feed which is pub sub hubbub enabled, you'll be given the updates of that feed within seconds of them being published. So let's talk a little bit about what loading in Feed API version 1 looks like so that we have a little bit of context. Here's a simple example of code using version 1 of the Feed API. And then I'll walk you through what exactly it's doing to load contents onto a page. The first thing that happens is we simply load the API. This is the Google Common JavaScript loader. We load the module called feeds, and we load version 1 of it. We then set an onload callback because the API is going to be loaded asynchronously via JSON-P. And we can't be sure that we can use the API if we simply run some code using the API immediately after that. So instead, we define a callback, which I'll show you in a second, which is going to use the Feed API code when we know that it's available because the load is completed. So in that callback function, we use the Feed API, and it's very simple. We create an object of type google.feeds.feed. We pass it, in this case, the URL of the official Google blog, which we want to use on our page. And then we call feed.load with another callback function. In this case, do something with feed contents. This callback function is going to be called one time after the fetch of the feed contents is complete. So the feed contents are fetched asynchronously and passed into this callback, which is defined below. So that result object is going to contain the contents of the feed. But before I implement this for you, I want to talk a little bit about what this result format looks like. So you may be familiar with what feeds look like typically. They're normally done in XML, either RSS or Atom forms of that. This is a simple RSS feed. You can see that the title and link and description of the feed are represented here under the channel tag. Then there are multiple items which represent the entries in the feed. Each of them also have their own title, link, and description. And this is basically what an RSS feed looks like. Now, the unfortunate thing about this, if you're working on a web app, is XML is heavyweight. It's complicated to parse. You really don't want to deal with this in your web app. So what we do in the Feed API is we map this in almost a one-to-one mapping to a JSON representation, which is easy to use in JavaScript. And as you can see, if I flip back and forth between these, you can see the mapping is pretty straightforward between the two formats. Now, JSON, on the other hand, if you're familiar with it, makes it very easy for you to just use the object as a native object in JavaScript. So we can look for member feed, member title underneath that, and get the title of the feed, and so on. So given that, I can implement the callback function here. And you can see I have a very simple for loop here that simply iterates through the entries and alerts a dialog box telling me what the title of each entry is. Very simple, not very useful, but you could do some pretty powerful stuff with this JSON result format in this callback function. So let's look at a demo that's built with this API. So here's a page which is aggregating a couple of my feeds, a WordPress blog and my Buzz feed. And you can see that I'm collating the two together in the order that they were posted. And it's just got a bunch of things that I've posted onto these feeds. So what does the code for this look like? The code starts here. As you can see, I'm doing some of the same things that I did in the sample earlier. I'm loading feeds version 1, setting an onload callback, this time called init. In the init function, then, I'm declaring two different objects of type google.feeds.feed, one of which is my Buzz feed, another of which is a WordPress feed here with this WordPress URL. I'm also using a function call I didn't introduce here, which is simply setting the number of entries I'm interested in loading on each feed. And I'm just setting that right now to max entries, which is the max number of entries I want to display on the page. So I want to display 12 items on the page. I'm going to load 12 from each feed and then collate them and get rid of the extra ones. Then I call .load on each of these with a separate callback, one defined for on Buzz updates, one defined for on WordPress updates. In each case, I simply add an entry to the page with a different CSS class. In this case, Buzz update is the CSS class, and the other WordPress update is the CSS class. And that allows me to add custom styling, as you can see here, the WordPress logo for WordPress updates, the Buzz logo for Buzz updates. Then I have some code here that we don't need to go into the detail of that's simply creating the divs to put onto the page, collating them by publish date, and getting rid of some of the extra ones at the end since we're loading twice as many as we actually want to display in the beginning. And that's really all there is to it. There's also some CSS and so on that's doing the styling that's on the page. OK, so that's cool. What if I wanted to get the updates from these feeds in real time so that my users could see them come in without having to refresh their page within seconds? Well, as Moishe talked about, one thing that we could try, kind of the old state of the art, is polling. But there's not only the reasons that Moishe talked about that all apply in this case as well, but there's also a couple of things that we need to consider specifically in this case. For one, we have multiple levels of cache which prevent updates from showing up very quickly. The Feed API gets lots and lots of traffic, as was mentioned in an earlier talk this week. And so we have to have some caching to handle that. So there could be anywhere up to a few minutes of lag caused by the caches holding on to updates of the popular feeds. In addition to that, if you pull too much, and your traffic may look abusive because you're hitting the same thing over and over and over again. And you may get either throttled or blocked. Also, if you pull too little, you might as well just not, because you're not getting things quickly anyway. So here's the example I showed you earlier. I'm proud to introduce very simple changes that you can make to this to use Feed API version 2 and subscribe to updates in the browser without polling. So here's all that I have to change, as you can see here, between Feed API version 1 and Feed API version 2 in order to subscribe to my feeds. As you can see, there's only 3 simple changes. First, I load version 2 of the Feed API. Then I create an object of type feed under the push namespace, which is the type of feed that actually supports the push updates we're going to do. The reason we have a separate namespace for this is simply so that we can also support the old loading cases in version 2, just in case you still want to do those kinds of things. And then I use the .subscribe function, which is on the push type feeds, which takes the same kind of callback, but now the callback's going to be called anytime there's new updates on the feed, instead of just once. You can see here, I'll point out that this callback actually hasn't changed at all. Currently, the result format of these is exactly the same as Feed API version 1. This will probably change with time, but I believe that we would like to keep at least the result format consistent between loading and subscribing in version 2, so that it's very easy to work between the two. So if you actually wanted to take some code that you had that does this already in Feed API version 1, your callback doesn't even need to change at all. Although in practical applications, you're probably going to want to do something different because it's no longer going to just be called once. It'll be called multiple times. You may want some items to expire and not continue to add things to your page and just make it grow indefinitely and kill your browser. You also may want to add some cool animation or something and things pop in. So let's look at the same demo that I showed you before, but slightly modified in the ways that I showed you in order to enable push updates. So I'm going to bring up the dashboard of my WordPress blog, and I'm going to add a new post. All right. Let me resize this so we can see a little better what's going on. All right. So I'm going to publish this to WordPress. And you can see WordPress is working on that a little bit. And there it is. Popped into my page without doing any sort of refresh in just a matter of a couple seconds. And I'll explain to you in a second what actually went on behind the scenes. I can do the same thing with Buzz. So and we should see this pop in also in just a few seconds. There it is. All right, so what's different? Okay, thank you. So what's different? This looks very much like the demo code I showed you before. All that's different here, as I said before, we changed this to version 2. We have the same onload callback. Now we're using .push.feed. We're also using .subscribe in the same way that I explained. I'll also introduce this a little bit later. This includes a historical entries function. But this allows me to load some historical content so that the page doesn't start being blank at the beginning. Everything else after that is actually identical code, because in both cases I was loading more than I needed to at the beginning and discarded extra entries. In this case, as entries continue to come in, I'll continue to throw out the entries that are off the end of the list. All right, let's go back to the presentation. Get a drink here. OK, so how does this work? In order to explain that, I need to first introduce you to something called pub/sub/hub. So you may have seen Brett Slatkin's talk on this earlier this week, hopefully. If not, I recommend it. It was very good. And it will be on YouTube, hopefully very soon. You can also go to code.google.com/p/pub/sub/hub to get some details on this. Pub/sub/hub is a protocol that was invented by a couple of engineers, including Brett Slatkin himself at Google and some other people that they cooperated with, for the sake of turning feeds into streaming content streams. And the way that this happens is using a pub/sub model with a hub in between. So I'm going to brush over this very, very quickly. You should get the details elsewhere because this is a little bit beyond the scope of my talk, but I just want to introduce it very briefly. So the whole protocol uses HTTP posts. The subscribers are going to post their interest on a particular feed to the hub. They know which hub the feed uses by reading it out of the feed, which I'll show you very shortly. They tell the hub, I'm interested in this. Please post all updates to X URL. Then whenever the publisher publishes updates on that feed, it tells the hub there's new content on this feed. The hub fetches that new content and pushes it through a HTTP post to all of the URLs that have been registered for that feed. So there's a lot of content out there that's already pub/sub/hub enabled, and you may wonder how you can know which of those do this already. So one thing you can do very simply is this is the same feed I showed you before, and if you were to open up this feed and you saw something like this, link rel equals hub with some URL of a hub, you could know that this feed should be pub/sub/hub enabled, and you should be able to go to that hub and subscribe on it. Using the Feed API, however, you don't need to worry about those details. You can just know that this will work with Feed API version 2. Some things that actually come out of the box right now with pub/sub/hub support, blogs on blogger.com, on wordpress.com, on Typepad. You can also your own hosted WordPress blogs if you use the PushPress plugin. Tumblr, Posterous, all sorts of things that I've probably left out. Google Buzz, of course, as I showed you earlier. All of these things come with pub/sub/hub just built into the box. So you should have no trouble if you want to publish yourself to one of these kinds of feeds with pub/sub/hub enabled, or if you just want to consume the content from someone else. All right, so pub/sub/hub works pushing between servers. because it uses HTTP posts. But how exactly do we get from there to pushing to the browser? Well, the first thing that happens when feed.subscribe is called is that a request is made to Google's servers saying, please bind a comment channel for me. This is the same technology, basically, that Moishe was talking about earlier. It's going to bind a comment channel, and I think I'll show you a little bit about that a little bit later. So the comment channel is established, and then another message is sent to Google servers saying, I'm interested in this particular feed URL. So it's going to send googleblog.blogspot.com, and so on, send that to Google servers saying, please give me updates on this feed. I want to subscribe to it. So Google is going to check and see, OK, am I already subscribed to the updates on this feed? If it is, it doesn't need to do anything. But in a lot of cases, it may not yet be subscribed to that. So it's going to do the pub/sub/hub subscription step with the hub that was declared for that feed. So Google's going to send a URL to the hub saying, whenever there's updates on this feed, send them to this URL that Google controls and that we can receive subscriptions on, or that we can receive updates on. Then, at some point, the feed publisher publishes via pub/sub/hub, lets the hub know that there's new content. The hub fetches that content from the feed publisher, and it turns around and posts that to all of the subscribers, including the URLs that were registered by Google. Then Google can check and see, is anyone currently interested in this update? Is there anyone subscribed in Feed API version 2? And if so, it will push along those channels that were established for all the users that are subscribed in that feed. And that is really all there is to it. So I wanted to show you briefly. Let me go back to the demo I showed you a second ago and give you a feel for what this looks like. If we looked in Chrome Developer Tools, you can see a lot of the resources that were loaded here. I mean, you can see that we started the channel around here. So you'll notice, first we do a couple of tests to see what kind of channel, comment channel is supported on this browser. We do an initial bind to get a channel ID. And then we get this hanging GET request. And you can see it lasted for about a minute before it timed out, and then another one was created, and it continued to keep this connection open, right? In some of the cases, when content was sent along, it's probably much later on here when I did the pushes. Well, I'm not finding it. In one of these, we would see the content that was actually pushed along. The connection is held out as long as it possibly can, and whenever it closes, the client's going to reopen that connection and hold it out longer. And, oh, here we go. Here's exactly where I pushed to both of those feeds. You can see it went over this connection during that 1 minute that that one was open. And you can just see the content of the feed updates that were sent along there. So the client is holding this connection open, and as the content comes along, it's grabbing it and throwing it into the callback that was registered by the developer. All right. So that's how things are pushed. Let's talk a little bit about just some advanced usages of the API. So first of all, as you saw in the demo, I have the include historical entries function. This simply gives us the loading functionality of old Feed API version 1 without having to define 2 separate feed objects and 2 separate callbacks to handle those cases. What I can say is, I don't want my page to be blank when I first start, so I want to actually load 20 historical entries first, but I want them all to be passed to the same callback that I want the real-time updates to be sent to later. So that just makes development a little bit simpler. You could very easily also do this with Feed API version 1 if you wanted to, say, do something different in the case of the initial load and the case of the streaming updates later. But this just makes it a little simpler if the callback is the same in both cases. Another thing you can do is you can subscribe to multiple feeds, as I also showed you in the demo. You simply create 2 feeds of type push feed. And in this case, one is the official Google blog, and one is the Google Code blog. One thing to note in this case, we're only going to keep one channel open. As you saw, there was a single connection at any given time. And we're going to multiplex the updates on that channel. Again, as you saw, both of the updates for both feeds were on the same channel. So a little more advanced, if you're interested in knowing when the channel is bound and when it's unbound, this does not include the cases where the channel is simply, disconnected and reconnected immediately naturally. But in the case that, say, there's network loss and it's down for longer than anticipated, maybe you picked up your laptop and you walked between Wi-Fi hotspots, maybe the laptop was closed for a while, then you popped it open again, and it's trying to reconnect again. We have a couple of callbacks that you can use to identify when the channel has been connected and disconnected. So first, there's the onBind callback, which will let you know when you've been bound, and there's the onUnbind callback, which will let you know when you've been unbound. And you'll notice that these are on the google.feeds.push namespace statically. They're not on any particular feed object because, again, we share one single channel between multiple feeds. So these events would only happen once if the channel disconnected for all feeds that you've subscribed to. And then you just give it a callback, and that callback will happen. In this case, we just alert a dialog box saying what event change has happened. And finally, you may have a case where you want to subscribe your users to a feed for a while, and then they're not interested in that. Maybe they're interested in something else. So you want to unsubscribe and not get updates for that anymore, and you want to subscribe to something else. We have a simple unsubscribe function to stop receiving updates on that particular feed. Eventually, also, we currently don't have this implemented, but probably if you're not subscribed to anything, you've unsubscribed from all the feeds that you were subscribed to, we'll probably eventually just cut off that channel because it's not needed anymore. All right, so that's really all there is to it. If you want to get started, we're opening it up right now just for whitelisted testers. You can go to code.google.com/apis/feed/push to see the documentation and also to sign up on a form if you're interested in using it. And eventually, we hope to open this up to everybody, but we're just, taking steps to release it out slowly and see how it works. You can also play around with it a little bit at code.google.com/playground. Look under the feeds section and the push subsection of that. There's a couple of different simple examples, very similar. Does this mean that App Engine is going to support real-time commit push?
Yes.
Yes, absolutely.
Yes, it does.
OK, any other questions? We've got one here.
Yes, I was wondering, how does your JavaScript library compare to Strophe?
That's a very good question. So Strophe is the JavaScript Xmpp library.
Yes.
Is that correct? So we're not pushing full Xmpp down to the client. We're basically collapsing a bunch of it on the server side and sending just a very compressed JSON format down. So it's much less chatty than Strophe.
OK, thank you.
Yeah.
One more?
Is there any hope for near-term support for GWT widgets?
For what?
GWT support on the client side for the channel?
I'm sorry.
GWT support.
Oh,
for the
yes,
channel API.
yes. We are working on that, absolutely. Good question. Anything else?
We got a minute and a half. OK, I think we're done.
Yeah, excellent.
Thank you, everybody.